Cool. So I think this guys completes distinct to similar की हमने बहुत सारे examples कर लिए हैं. The next concept is similar to similar. In fact, the last concept for PNC. Please solve this question. Number of ways of distributing 17 identical balls in 3 identical boxes. So balls भी identical है, boxes भी identical है. 17 identical balls, 3 identical boxes. See, there are two methods. एक method तो वही cases बनाओ. But of course, you can't make cases here because 17 balls, right? So how do you make cases? 17-0-0, 16-1-0, 15-1-1, 15-2-0, बहुत सारे cases हैं. So the second method is start with ordered and then make it to unordered. So essentially, you first of all, see इसके अंदर ये भी identical है, ये भी identical है, right? You always have to play around with this. So you start that, let's say this question was number of ways of distributing 17 identical boxes into 3 different boxes. And then transform it from different to identical. So if this question would have been 17 identical boxes into 3 different boxes, तो answer क्या होता मेरा?
So 19C2.
Okay. Others, everyone? Number of ways of distributing 17 identical boxes. It is similar to distinct. Let the boxes be A, B, C. Sum is 17. Anything can have anything. So the answer is 19C2. Right? But what is the problem here? The problem is the boxes are different. So for example, a case like A is 1, B is 2, and C is 14. This is counted 3 factorial number of times here. I have to ideally consider it only once. Right? So now I will subtract the cases when 2 are same. 2A plus B is equals to 17. A can be anything from 0 to 8. A can't be equals to B. So in total there are 9 values. So simply I'll write 19C3 into 3 into 9 by 3 factorial plus 9 becomes my answer. Clear? Exactly same as what we have been doing. Just that instead of different to different, it was similar to different. So this changed. This 19C2 wala thing has changed. Even you guys will feel bored because it's all same concept that gets applied everywhere. For example, this question. Number of ways of distributing 5 distinct. By the way, guys, this is a very confusing. मतलब लोगों को समझ में नहीं आता कि यार कौन सा identical है, कौन सा distinct है. Distinct balls to 3 identical boxes. Same, I think ये question तो हम लोग इतनी बार कर चुके हैं, सबको आंसर ही याद हो जाएगा इसका. Same question, right? Exactly same question जो यहाँ पे था. This question. 5 distinct balls and 3 identical boxes. Like a question भी same है अब तो. Please solve this one. 21 identical chocolates into 3 groups. And I want you to just write the answer directly. I'll give this question as a homework because again it is exactly same. कोई difference नहीं है. 21 identical chocolates into 3 groups. The only reason why I included this question is यहाँ पे 3 groups है. Right? So the only concept here was group and not people. So when you're saying you have to distribute chocolates into groups, right? 21 chocolates के तुमको 3 groups बनाने हैं. So no group can be 0, which means if you say कि यार group number 1 has A chocolates, group number 2 has B chocolate, group number C has C chocolates, and the total chocolate should be 21. Whenever it is group, and you have to distribute something into groups. Groups तभी बनेगा ना जब minimum there is 1 item into it. So the only concept of group is that the variables can't be 0. So all the variables have to be greater than or equals to 1. That's the only concept here. So 1, 1, 1 दे दो. This is 18 plus 2, 20C2, right? But 20C2 तो कितना है? That is ordered. So you will subtract the cases. 3 into 2A plus B is equals to 21. Again 1. A can be from 1 to 10, total 10 cases, but this will have one case when A is equals to B because everything can be C. So I'll subtract 1. This is minus 3 into 9 minus 1 upon 3 factorial plus 9 plus 1. Same concept. Nothing new. Very good, Shubham. Right? The only new learning here is group is something which can't have zero value. That's the only learning. Rest to same hai. Just for the sake of completion, guys, we'll also end with this distinct to distinct. I want everyone to just write the answer. 2 seconds. First letter 6 ways, second letter 6 ways, third letter 6 ways, 6 into 6 into 6. Oral question. By this, number of ways of giving 5 different books to 3 students such that each student gets at least 1. That's a good question. It is distinct to distinct with some restriction. To go back to basics, cases now. Again, advanced question. The correct answer to this question is 150. It's an LOD 3-4 type of question. Let's see. Number of ways of giving 5 different books to 3 students such that each student gets at least 1. Basic method, right? Because there is some constraint, I'll go with the basic method, that is 3 students hai, say student 1, student 2 and student 3. 5 books deni hai, such that each student gets at least 1, right? So at least एक तो मिलनी चाहिए, बची भी 3. So 3-1-1 is like one level of distribution. 2-2-1 is the second level of distribution. There could be only 2 cases, right? So simple, right? Permutation combination सब allowed है. 5 books है, 5C3, 2 books में से into 2C1, into arrange it, 3 factorial by 2 factorial number of ways. Similarly, 5C2 into 3C2 into 3 factorial by 2 factorial number of ways. And solve it, you will get 150 as the answer. Very simple. The very first question that we did even before going into similar, distinct, similar was a question where I've explained how do we solve questions by fundamentals. So this is the first method by fundamentals. The second method to solve this is, see, अगर कोई भी constraint नहीं होता, for example, this was not mentioned, what would have been the answer? Anyone? Just unmute and ask. Sorry, and answer. If there would have been no constraint in the question.
3 to the power 5.
Very good. If there is no constraint, first book can go to 3%, second also to 3. So the answer would have been 3 to the power 5. But this includes cases which we will have to subtract. So can anyone think of what all cases will we have to subtract now? So can I say when at least one, when say exactly one student got 0, when exactly one student got 0 books, plus when exactly 2 students got 0. These are the 2 cases that I'll have to subtract, right? Because every student should get at least 1. So when any of the student is not getting 1, I'll subtract that cases. So when any one student did not get 1 and when any 2 students did not get 2, right? Is this clear? That this is what is asked in the question. Anyone has doubts here? Perfect. If this is clear, can someone tell me ki exactly 2 students getting 0? In how many ways can exactly 2 students get 0? So 5 books से 3 students को देनी है such that exactly 2 students get 0 number of books. Find the number of ways. It could be any 2 students out of these 3, right? So first of all, I'll choose any 2 students in 3C2 number of ways. Once I've chosen them, they have to get 0 books. ठीक है? So all the books will go to the third person. So the total number of ways for this case is nothing but now exactly one student got 0. First of all, let's choose this one student. 3C1 में I have already chosen कि यार इस बंदे को तो 0 मिला है. So how many ways are there? Now this is a question कि यार एक student को already 0 मिल गया, right? So we have 2 students. So we have to distribute 5 books to 2 students. In how many ways can I do it? In how many ways can I distribute 5 different books to 2 students? In 2 to the power 5 number of ways. But it will have cases when all the books are given to any one student. See, isme to each of these 2 students should get at least 1 book, right? So it will have cases when all the books are given to any one student. In how many ways can it happen? 2C1. Out of 2 students, you choose any one student who will get 0 and give all the books to other student. So that needs to be subtracted from here. Now this becomes your answer. 3 to the power 5 is what? 243. So 243 minus, what is this? 32 minus 230 into 390 plus 3. Sorry, minus 3. So if you solve it, you again get 150 as the answer. Was it clear, guys? Both the methods? You can choose whatever method, but are both the methods clear to you? Now I want an answer. Which of these 2 methods, first and second, is easiest for you? Which one would you use in exam? Just comment.
First one.
Just comment which of these 2 methods would you prefer to use. So that next time I don't waste my time in explaining a longer method. It will give me as a feedback. Everyone, come on. So I think, guys, now we have officially completed all the variants, all the possible variants of PNC. Now you can go back, pick any book, any mock, anything, any CAT question from PNC. It has to be from the concepts that we have discussed. It can't be beyond it. Right? The only one concept that is left is in concept. I leave it on you guys. I only need 10 minutes to finish this concept. If you want, we can have a class tomorrow. If you want, we can finish PNC today and tomorrow you can have fun. You can revise it. I'll upload the session. Okay. By the way, just for your boost of confidence, we have completed 128 slides so far for only PNC. So that many questions you guys have already done till now. A question is that there are 7 letters, 5 envelopes. The direct number of ways is 5 to the power 7, right? First letter has 5 envelopes, second also 5 to the power 7. But if I ask you a question, that okay, you have 7 rings and you have 5 fingers. In how many ways can you arrange it? In how many ways can you arrange 7 rings in 5 fingers? Or at least tell me, will it be 5 to the power 7?
No.
Why?
So rings cannot be identical. Fingers are not identical.
No, 5 to the power 7 is also distinct to distinct. 5 to the power 7 means nothing is identical. What is the problem here? If I use 7 rings, 5 fingers, first ring can go to any of the 5 fingers, second ring can also go to any of the 5 fingers, and so on and so forth. Can I not write the same expression, 5 to the power 7?
So can we wear 2 rings in 1 finger?
Yeah, why not? Assume you can do it. I just think like it has to be either yes or no, right? Either you are saying yes or you are saying no. You can't say I don't know. See, the only catch that you can't do it like this is, first, like rings can be arranged, right? Like rings can be placed above or below another ring. So the only catch is this 5 to the power 7 is plain and simple. First ring 5 fingers, second ring 5 fingers. But no, that's not correct. Once you have placed one ring, then you have 6 positions, 4 fingers, and then in the finger that you have placed the first ring, either the ring can be above it or it can be below it. Is it making sense? Why will it not be 5 to the power 7? Because you can also arrange the rings internally. Envelopes mein to you can't. But ring 1 upar hai, ring 2 niche, or ring 2 upar hai, ring 1 niche. These are 2 different cases, right? And that's the reason why you can't directly apply this. Is this clear? Like, what's the difference between letter envelope type of question and rings and fingers type of question?
Yes, sir.
And by the way, this is only applicable to rings and fingers. So CAT के scope में it's only rings and fingers. So जब भी ring finger देखो, you can remind yourself of this. But then if question is asked that in how many ways can you put 5 rings in 3 fingers? 5 rings है, 3 fingers है. Rings can be different. Rings are different. Fingers are different. How many ways do you do it? So how do you do it? You first of all
Select rings.
no. So first of all, you put 5 rings into 3 fingers. You assume that okay, rings are similar. So assuming that rings are similar, there are 3 fingers. You place it first of all, and then you try to arrange them. Maybe take 1 minute, 2 minutes, think about this, and then let's discuss it. So how about you just assume rings to be similar? You just place 5 similar things into 3 fingers. Let the 3 fingers be ABC. Put these 5 rings into 3 fingers and then internally arrange them. So by arrangement, you will take care of this. यार ऊपर कौन सी आएगी, नीचे कौन सी आएगी, and all. Right? So either make cases and do it like that, or you assume rings to be first of all similar. So similar to distinct. How do you solve it? A plus B plus C is equals to 5. Right? Any finger can have any number of rings. The answer is 7C2. Once it's 7C2, rings can be arranged internally. Upper, niche, between the fingers. So you just shuffle them. 7C2 into 5 factorial becomes answer to solve ring finger type of question. By the way, this is the only concept that is there for ringing concept. Ring and finger. You always assume rings to be first of all similar. Put it in fingers using similar to distinct wala concept that we learned. Once you have done it, you try to arrange them internally. That's it. Try to apply this concept in this. And then I think you guys will gain confidence on this concept. So at least always by default, you assume rings to be different unless it is given in the question. Number of ways of putting 8 rings into 5 fingers such that each finger has minimum 1 ring. This is the second last question for today. The only thing is the concept. Yeah, Dhruv.
सर एक चीज है, जैसे मैं लाइक फर्स्ट ऑफ ऑल हम अज्यूम करते हैं कि रिंग हमारी लाइक सेम है.
Correct.
ठीक है. सो लाइक A plus B plus C plus D plus E equal to 8. ठीक है.
Correct.
और हम एटलीस्ट 1 फिंगर लाइक 1 रिंग देंगे टू ईच फिंगर.
Correct.
सो उस तरीके से हमारा आंसर आता है 7C4.
Correct.
ठीक है. नो सर, ये 8 फैक्टोरियल वाला मुझे लाइक मेरे को लग रहा है कि मैं गलत कर रहा हूँ.
क्यों?
रीजन बीइंग कि सर लेट्स से हम कंसीडर करें कि हमने ऐसे किया 2 2 एंड 2 1 1 इस तरीके से हमने डिस्ट्रीब्यूट किया. ठीक है. तो 2 फैक्टोरियल इंटू 2 फैक्टोरियल इंटू 2 फैक्टोरियल इंटू 1 फैक्टोरियल इंटू 1 फैक्टोरियल ऐसा नहीं होना चाहिए. लाइक एक फिंगर में जो हमारी से मान लो 2 रिंग डाली है तो वो तो आपस में शफल होगी ना ऊपर नीचे. 8 फैक्टोरियल क्यों कर रहे हैं?
8 फैक्टोरियल अपन ये कर रहे हैं. सी एक फिंगर में अगर तुमने मान लो 2 रिंग्स डाली है R1 R2.
हाँ.
8 फैक्टोरियल से क्या होगा? से फॉर एग्जांपल यू हैव एक इसको सिंपल अपन इस तरीके से करते हैं. राइट. दैट यू हैव फिंगर 1, यू हैव फिंगर 2. फिंगर 1 में दो रिंग्स है R1 R2 और यहाँ पे मान लो एक थर्ड रिंग है R3. राइट. So in how many ways can you arrange them? In the question, right? So, अच्छा, okay. See, always finger 2 में एक ring तो होनी है. So we have 3C1 number of ways.
3C number of 1. हाँ, right.
Now ये जो 2 rings है, they can be arranged in 2 factorial number of ways, ऊपर नीचे. So always like whether you think it like this or you simply say कि ठीक है यार there are like see essentially selection तो तुम already एक कर चुके हो. जिस ring को जहाँ जाना है वो तुम पहले ही बिठा चुके हो using that NCR वाला thing. Once you have done it, You're just arranging, you're just shuffling them. So 3 factorial will give you all the number of ways when this R1 goes here, R3 comes here, or this goes there, this comes here. This is just shuffling, right?
ओके वो 7 फैक्टोरियल जो हमारा 8 फैक्टोरियल में हम सारी रिंग को सबको शफल कर रहे हैं ताकि
यस हम लोग सिर्फ शफल कर रहे हैं. फर्स्ट की जगह सेकंड आ गया, सेकंड की जगह फर्स्ट आ गया, थर्ड आ गया, फोर्थ आ गया. यू आर नॉट लाइक उसमें ये नहीं हो रहा दैट यू आर रिमूविंग वन रिंग ऑल टुगेदर.
ठीक है.
Right? So always whenever you are confused, I personally take this approach here. Even when I am confused, I'll simplify the question. Let's say 2 finger होती, 3 rings होती. Then is 3 factorial making sense or not? If yes, then yes, expand it. If no, then yeah, something is wrong.
ठीक है.
So the answer to this question is 7C4 into 8 factorial. Last question for the day. Come on guys. 2 seconds का भी नहीं है ये वाला question. Last question has to be the simplest. Can I expect all the 12 students to answer this? 8 identical rings, 5 fingers. See, when we see 7C4, we did not assume it, right? 8 identical rings and 5 fingers. It's okay. Wait, in the last question. Oh, sorry. Yes, my bad, guys. Yes.
So it should be 12C4.
Yes. Very good, yeah. It has to be 12C4. My bad. Sorry. In the last question, I forgot that in the last question there was a constraint that every finger should have at least one. That was the constraint in the last question. Here, there is no constraint. If there is no constraint, the answer has to be 12C4.
Yes.
Very good. Thanks, yeah. Thanks for pointing out.
Yeah, no problem.
But like all of you made the same mistake. Huh? People who said 7C4, is it clear? Why it should not be 7C4? 7C4 to tab tha when there was a constraint, right? Last question we had this constraint, each finger has minimum 1. Yahan pe to there is no constraint. Answer will be 12C4. Clear? Everyone? Perfect. So, how was the PNC? I think one of the longest session you will find in PNC. मतलब इतना लंबा session होता नहीं कहीं PNC का. But was it worth it, guys? Is it clear now? Are you confident that you will be able to solve every question of PNC if you go back and revise?